Okay, so I'll go ahead and restart here. So basically today our goal is going to be to create a part in SolidWorks, and it's going to be a surface part today. The reason I'm choosing to do a surface is because typically surface modeling is more difficult than solid modeling, at least in my experience. That could not ring true in some cases, but and also the other reason is because we do a lot of shell modeling with composites, and I see in the future a lot of people being interested in composites as cars get lighter. So shell modeling will probably be the best thing for you to know, and then you can go ahead and apply that logic to solid modeling as well. So we're going to do a brief refresher in SolidWorks on how to make a shell, just a really simple part that'll show why HyperMesh can be useful in terms of editing your mesh. And then we're going to go ahead and import it into HyperMesh. And then we're going to play around with the mesh that's on there that is automatically generated. And we're going to make some connections, show you how to remesh, show you kind of the purpose of what a mesh is, because I know not everybody here is super aware of what a mesh is. And then we'll go ahead and show you how to import it into ANSYS Workbench, which is really simple. And that will be a gateway into the second video, which I've already uploaded a few months ago, which is how to use ANSYS Workbench. So you'll just apply the logic that we use today to that, and you should be set to go modeling in ANSYS. So before we do that, does anybody have any like baseline questions about what's going on or terminology, anything like that? Awesome. Okay, so I'm going to go ahead and share my content here, and we will jump right into SolidWorks. So I've actually been thinking over the last few months. Can everybody see my screen? Okay, hopefully. Okay, cool. So I've been thinking over the last few months, SolidWorks is fantastic for certain things like modeling solid parts. I mean, that's kind of inherent in the name. And it's not great at things like surfacing. So there are better programs out there. I've actually done some research on which ones are kind of the most user-friendly. NX is probably the next best program out there, if not a superior program. It makes surfacing really easy. It's very user-friendly. It's not confusing to look at. The screen's not garbled. So we may do surfacing in the future on that, but for now we're going to stick with what we all know, which is SolidWorks. So we're going to start by making a part. I'm going to keep the units as inch pound second, and go ahead and load this. So, okay, it's going to take just a sec. Okay, so we've got our part screen loaded. I'm going to go ahead and reveal a plane by right-clicking and then hit show. And then you can hit the space bar and orient your screen wherever you want. Just a tip if you don't know that. So I'm going to go ahead and look at the top plane. And I'm going to start by just making a sketch. So right-clicking on the top plane, clicking that sketch icon, and I'm going to go ahead and make just a rectangle. I know that there is a rectangle tool, but I want to customize the size of mine. So I'm going to go ahead and make this a 12-inch, so 1 foot by 1.5 feet. So we're going to do 18 inches here, and we're going to do 12 inches again. It's going to meet up there and back. And you can see it's been highlighted blue, which means it recognizes that that is a closed shape and that could be turned into a surface. If it's not highlighted blue, it means it's not closed. It's going to exit the sketch, go to here, this little arrow, and I'm going to pin this here. It loads, it kind of collapses by default. I'm going to go to Insert, Surface, and then Fill right here. And it's going to automatically select that. It's the only thing in the drawing, so that's what it knows. And that's the patch boundary. So what we're going to do is just hit the check mark, and we have a surface. And if you don't remember what the difference between a surface and a solid is, a surface is three-dimensional, but it is infinitely thin, and it is different than modeling a solid. So there's a surface, very simple. And what we're going to do is we're going to create an instance in which you would want to be able to know how to use HyperMesh's tools. So I'm going to sketch again on this plane, and a T-junction, which Dr. Kyle has talked about and I have talked about before as being a huge modeling challenge. So I'm going to make it really ugly too. It's going to be just a line with no specific coordinates here, and it's going to be really, really, really ugly, just like that. Okay. Now I'm going to right click and hit select, which ends my chain, and I'm going to exit the sketch. Now we're going to go to insert surface, and we're going to do what's called extend, and that takes a line or a series of lines, and it will, oh, excuse me, this is, I meant to hit extrude, that's not what I meant. Surface, let's see if I can find it here. Extrude, sorry, surface extrude, which extrudes a line in a direction. So I'm going to extrude it upwards like this, and that will be good. So we'll go ahead and hit the check mark. And now I've got this just arbitrary part here. So this is a surface 2. All of these walls are infinitely thin, which is going to go ahead and present a nice modeling challenge for us because the HyperMesh program, or any meshing program, is going to automatically recognize these as being different parts. It's going to mesh them independently, and it's not going to treat it as one solid part. You and I know that we intended this to be a solid part, but there's not much we can do to change that at this moment. So what I'm going to do is I'm going to save this. Got the screen sharing in my way here. So we're going to go save. I'll save a solid part file. It's always a good idea to save it. I'm going to do it in a downloads folder. So save a solid part file. And then what I'm going to do is I'm going to go to save as again, and I'm going to save a copy as an IGES file. Now, there's a couple of different ones that you can do. IGES is usually pretty friendly in terms of interacting with other programs. There's also what's called a step file, an STP or an STEP. These are both great. There's an STL file. These are all CAD formats that you can use. IGES is what I prefer. So I'm going to go ahead and save that. So now we're going to have that in our downloads folder. And I want to go ahead and mesh this. So I'm going to search right here under Altair. Let's see, there it is, Altair 2019. And we're going to go down to a program called HyperMesh 2019. And don't confuse this with HyperWorks. It's just HyperMesh 2019. So we're going to click on that. And it fires up pretty quickly here. And I should mention too that Altair has a Hyper suite basically, HyperWorks, HyperMesh. They all integrate with each other and use the same file type. Each program is capable of slightly different things, but for what we're doing, this is the best. So, here's the interface. This is the default screen. And you can see that there's a little box right here that's popped up. It's called User Profiles. Now, this you want to interact with right away. Don't hit cancel. So we're using the application HyperMesh right here. So that's correct. And this is what we're going to want to export it to. So in our case, we want to export to ANSYS. Now, all of these are different solvers that you can use to run your FEA. You can use Nastran, you can do Abacus, any of these programs. We also have Abacus here at Western. So I'm going to hit ANSYS, and I'm going to hit OK. And basically what that's going to do is it's going to load some custom tools in this program that are unique to ANSYS that I might want to use before I import it to ANSYS. I might want to prepare this model using ANSYS specific tools. And if you look down here, you go to Utility, and you see there are some ANSYS tools that you can click on. And click on Geometry and Mesh, and it pops up with different tools that are unique to ANSYS. So I typically don't interact with those because I haven't done anything complicated enough to need it. But for now, we're just going to go to File. We're going to hit Import, and then we're going to import a geometry. So you click Geometry, and right here, there's a little file icon. Just click that, and it's going to auto-detect the file type, so I don't have to change any settings. And go to my downloads where I saved it, and I'm going to click on an IGES file. SolidPart is kind of proprietary to SolidWorks and doesn't like to interact with other programs much. So I'm going to import the. I usually highlight it just for good measure. You can change the import options here. Typically, there's not much to change for what we're doing. So I'm going to hit import. And there's our file. So I'm gonna hit close and move this just a little bit, just so I have some more screen space. That should be fine. Okay. Now, to control this, I know you can't see what I'm doing with my keyboard, but you have to hit the control key and hold it down, and then left click to rotate. And you set your rotation point by a quick single left click. See right there, that white box that popped up? That's my new rotation point. So now then I hold down control, I've been holding control this whole time, and I do a long click to rotate about that new point. Set a new point by clicking rapidly and rotate. In order to pan, you hold down control and use your right mouse key, and that'll pan around the model. Zoom in and out by holding down control and rolling your scroll wheel, and that is the basics of how to navigate. So if you want to fit the model to the screen, you hit the F key, and it'll go ahead and fit your model and just put it exactly as you would want it. So as you can see, it's just as we made it in SolidWorks. There's nothing that's been done to it so far. So we are going to want to create a mesh. And note that this is a surface mesh, not a three-dimensional solid mesh. So we're going to go to Mesh, Create, and then right here there's something called 2D Auto Mesh. And since this is it's technically a 2D, we're gonna use that. You see a lot of confusing stuff right here. There's not much to it actually. So right here there's a drop-down menu under this highlighted portion. Surf stands for surfaces. You can also select elements. We're gonna stay to surfaces. And here is your element size. Now, I'm not an expert on exactly how this is based. I believe it's like a portion of the model scale. I could be wrong, but I usually start for part sizes that we do at around 0.5. And you can look more into the element size and what that unit is if you want to know more about it. And I'm not going to change anything here. We're just going to match it by the size. And that's what we just entered here. These are not important for what we're doing right now. And so we're going to go ahead, click on this. Excuse me. We're going to hold down the Shift key and the left click, or draw a box around all the surfaces here. And you can see it's highlighted them right there. And now what we can do is we can go ahead and hit Mesh. And very quickly it has come up with a mesh, which is nice. Sometimes it'll take longer depending on how complicated your geometry is. And we kind of see that it's created these numbers here. And these numbers are the amount of nodes that have been spawned along an edge. So a node is, I'll zoom in here, a node is the exact intersection right here. So that is a node where these four lines intersect. An element is one of these squares. So an element is different than a node, and the count is different than a node. So this is tracking how many nodes have spawned. And that's all nice information. You can actually use that later. You can spawn a mesh depending on how many nodes you want along a surface, which can be really helpful. Now, if I don't like this mesh, what I can do is I can hit this reject key, and it will eliminate the mesh. And then I can rescale my elements by hitting, let's say, 0.75. Maybe it's too small that I wanted. And I'll mesh it, and it will... it looks like it did the same size. Strange. Go ahead and hit back. But anyway, you can change the element size. 0.75. We'll try that and see if it changes. Yeah, you can see that this is no longer 30, it's 20, because now we're using a larger element, so it can fit less of them there. Now, typically for something this size, I would actually go with a small mesh. You want it to be tighter, you want more elements, it gives you more detail. Kind of think of it like, right? A 4K computer screen gives you lots of detail. It tells you, it tells you information without as much pixelation. But here you can see this is like a 360p TV. It's not very detailed. Your analysis isn't going to be very accurate. But for the moment, I'm going to stick with this inaccurately sized mesh because it's going to help speed up the tutorial a little bit. I'm going to have to interact with less elements, but just know that you're going to want to shrink these down when you're doing your projects. So I'm going to say that I'm happy with this mesh, artificially so, and then I'm going to hit return. And now you can see that it's kept the mesh, and you see this screen still here, and I go ahead and cancel out of that. So there's different things we can do, and I want to point out some problems that have happened with the mesh that you may have noticed already. So if we zoom in here, you can see this is not a continuous mesh. Like I said earlier, the computer thinks that these are two different parts. I know that they're the same part, but the computer does not know that. So it's meshed both of these independently. That's a problem because when I try to apply loads to this part, it's going to not translate the forces into the mesh the way that I want it to. It's going to be an inaccurate representation. So what I need to do is connect these nodes to each other. So I'm going to go ahead and go to mesh. Actually, I'll just show you the easier way to do it. Hit the F3 key, and you can see that this screen pops up down here, and you can change a few settings, but right now we're just going to stick with equivalence. And so first, click a node, and see where that. Oops, sorry, hit the F key and recenter. Sorry, my dog is barking in the background. Okay. Oh, it's lagging. This is very slow. Okay. Let's try this again. So we're going to replace a node. So we're going to click a node, like this one, for instance. And you can see it's selected the node on the surface, the flat surface that was on the top plane in SolidWorks. And what we're going to do is replace that node. Wow, it's lagging a lot. I'm sorry. This is really bad. My Wi-Fi is terrible. Okay. Click that surface, click this node, and then you can see it's snapped. So now it's connected. And we're going to go through, and we're going to do this for each one. And this is a very tedious process. See, here you can see that I made an error. And what it's telling me is that by uniting this node with this node, it's going to essentially destroy an element. And you can do that if you want, but you have to be cognizant of what that means. It means that you will have one less element, and it may cause other nodes to jump around when you do this. So if I hit yes, you can see some weird, yeah. So here you can see that this is united, and that's not something you want. So I'm gonna hit the back key on that one. Anyway, so I'm going to connect just a few more. I'm not going to go through and do this entire thing because this would take probably 5 or 10 minutes to do. But anyway, you get the idea. So you can connect these nodes, and that's important because then it's going to translate the force. But you notice right here, we've got these really weirdly shaped elements. And if you know or do any light reading on finite element method, you really don't want to analyze strange shapes like this. It's not great. Squares are the best. Cubes are the best. And triangles are also good. But you don't want to analyze something like a parallelogram, or this odd shape, or something that's four-sided, but not exactly a triangle, not exactly a square. Like here we got 1, 2, 3, 4 sides. That doesn't really make sense. So what we're going to do is we're going to refine the mesh in that area by remeshing. So we're going to go to mesh and then edit, and we're going to do the elements part right here, and then go down to rebuild mesh. So nice this program is that it will automatically keep this connectivity. It's not going to remesh this and separate them again. It'll actually keep them connected. So I'm going to click, actually, let me do one thing real quick. I'm going to connect this node and this node. There we go. So it behaves nicely when I try to remesh. So we're going to edit again, elements, rebuild mesh. And you can see here, elements is selected, which is short for elements. And I can go ahead and click different elements that I would like to remesh. And you can see they're highlighting. And of course, it's going very slowly because of my wonderful Wi-Fi. just like this. And you can actually hold down the Shift key and highlight a section of elements if you want to remesh those, like that. That's probably a more efficient way to do it. Or you can just go through one by one like I'm doing right now. Anyway, so I've selected the ones that I'm interested in remeshing. I'd like actual shapes to come out of this. So I'm going to go ahead and edit the criteria. So hit edit criteria, and you can change things like the target element size, and you can change things like the minimum size, the maximum size. You can do advanced stuff like warpage. Angle generally refers to where the mesh decides if I have a sharp corner, where it decides the minimum angle is before I can create a node for those two. Instead of doing one node here and one node here, it'll bridge them. So you're setting this angle. So you can edit things like that. Generally, we don't have to do that, which is nice. So I'm going to keep the target element size at what I had it set at the beginning and just hit OK. And then, since I have all my elements selected, I'm going to hit rebuild. And this is kind of nice. Obviously, if I had connected all of these nodes, I'd get a much prettier mesh, but you can see that it's made some edits to form more friendly shapes for the computer to analyze. So you've got like a square, a triangle, a rectangle. I mean, roughly so, but they still, they're a bit more friendly. And it's maintained its connectivity. So that's good. And like I've said 3 times now, I never around, but for the sake of tutorial, this is what I want to show. So next, we are going to, let's check my notes here. Next here, I want to show you how to split a mesh. So let's say that you've got this massive element for some reason, and you just don't need it to be that big. One way that you can edit the mesh is to go to Edit, Elements, and you can do a few different operations here. You can do split, you can do combine if they're too small, you can do detach and print, extend, etc. I would like to, let's say I'll combine a couple of elements here instead of splitting them. Let's say that these 2 elements, for whatever reason, I decide are too big. They're not, but we'll just say that they are. And let's see if it'll let me select these here. There we go. So I've highlighted those 2, and I'm going to go ahead and hit combine, and now it has made 1 element, and then it's done some strange things here. I'm not exactly sure what it is thinking there. Let's hit combine and see if it reacts. Well, I'm not sure why I did that, but anyway, so you can combine elements as the main point, and you can also split elements. So let's say that I would like to split 1 square into 4 squares. So I can go to Edit and Elements, Split. So I'm going to click this one right here, or well, let's do this because this is more square-like. And you can change the settings here. You can split all sides, divide it into quads, so 4 different pieces. You can do from the midpoint of the shape into 4 different pieces. You can do midpoint into triangles. Just for demonstration, we're going to hit midpoint to triangles. I'm not saying this is the best choice, it's just something you can do. And we'll hit split, and you can see that it has gone ahead and made 4 different triangles. This is acceptable. You can do this, and here's the reason why. It's really important that a node stays as a node. What you don't want is for there to be a line that goes from the center point to the middle of an element, because that's not really a node. That's kind of strange. Like, let me show you what I mean. Let's change this to quads. Oh, strange. Hang on. Hang on. Midpoint to quads. That's probably what I mean. Back, split. There we go. Point to quads. I don't personally like this much because you have these small elements and then you've got this border right here. Generally, I like to avoid that. But anyway, that's just something to be aware of. So, and the reason is because you have a dramatic size change right there, and that's not great.
The
Dr.
other problem you have with that is that you have a mid-side node in the middle of one of those elements, and you're dealing with linear elements right now, so they don't have mid-side nodes.
Right. Yeah. And then, correct me if I'm wrong, but the abrupt size change can also decrease the accuracy of your analysis because the stress may not, like changes that happen between the large node and the small nodes may not be accurately captured. Is that true?
Mm, I don't know that I'd say that. Usually, what happens is if you've got uh, relatively um, low changes in gradient across your mesh, you can use large elements in that region. But when the gradient starts getting really steep, that's when you need to refine the elements so you can capture the actual stress.
Right. Okay. That would make sense. Yeah. Thank you for jumping in. Um, yeah. So you do have the ability to split these. Be careful about how you do it. I have had to do it, and generally it's me iterating between making a split, remeshing the area, making a split, remeshing the area, just kind of jumping back and forth until I'm happy with the way it looks. And there's some other things you can do here. You can clean up elements, you can smooth them, check your quality index, which is good. So for example, I hit quality index here, and it gives me a few statistics about my mesh, and it gives a percentage breakdown too, which is good. Tell you the percentage that have failed. Some elements do fail when you make it, and it's unrealistic to expect every single element to be unfailed. There are some parts of your model that may be so obscure that the computer does not know quite how to handle it without you interacting. So without any revision, this is not a bad percentage right here. But so you can see eight elements have failed. And that's not necessarily detrimental to your model, just so you know. And it will tell you which ones have failed. So the next step of our process is going to be exporting the model to ANSYS. So first, what I will do is go to this toolbar right here in the bottom right corner. You can see that I have a few different options: geometry, 1D, 2D, 3D. I'm going to click 2D because we are working with 2D elements. And I'm going to hit element types down here. And you can see, again, we have a 1D, 2D, and 3D option. I'm going to go to 2D again. And it has decided in the program that the shell elements, now each of these elements is different. The characteristics of each element varies. So the info that shell 63 carries is different than the info that, say, shell 157, shell 154, all of those carry, or excuse me, shell 143. So you can change that. Do make sure to read up on what each element type means. They're used for different types of simulations. I'm going to stick with 63 for the moment, unless Dr. Kyle, you know something about that.
60. I don't know what does 63 mean now.
Yeah, do you happen to know the different shell types?
Oh, the different shell types.
Yeah.
No, I don't. I mean, as far as ANSYS is talking.
Well, in this context, it'd be in HyperMesh, but yeah, ultimately we care about ANSYS.
No, in this context, I'm not sure.
Okay. I know there is reading you can do about it. For sure, Abacus has a program that teaches you, or excuse me, a web page that teaches you about the different elements and their types and titles. So it's kind of a dry read, but it is important. So make sure to do that before you do your project. Anyway, so I see that they have shell 63. So I'm going to just accept that as correct for now, and I'm going to hit return. Although if you do want to change them, just left click and then select your shell type. But anyway, now I go to ET types right here. Excuse me, not right there. We're going to go to ET type over here. It's the same menu, just a different format. So hit ET type, and you can see it's blank. There's nothing here. Basically, what we're setting is the elements that we want to export. Hit new, and just leave ET type number as 1. It's just a designation. ET type name, that's fine. You don't have to change that. Element type. Now, this is the type of element that I want to categorize the model. So I'm going to go to shells. And remember, we're using shell 63. So we're going to go ahead and click that. And we're going to hit create. And you can see it's popped up right here. And close this little dialog box. And you don't need to interact with this anymore. You're just going to go ahead and hit close. You've created the element type. Good for you. Go to component manager. Now, you can see that this is treating the model as what it calls, it's treating the model all as one component, if that makes sense. It was titled part 1 just because I didn't change it from SolidWorks, so don't be confused. HyperMesh is not naming it part 1. It's just saying that part 1, our model title, has one component. Now, the ET reference number right here, well, we just created one of those. I want to say that this component is made of shell 63. So I'm going to right click, and I'm going to go up to what's called editable, left click on that, and now I'm going to assign some values. So I'm going to say, all right, I want to name all these elements in component 1 ET reference number, and here's the one that we created right here, shell 63, and I'm going to click on this to highlight it and hit set. And it's going to say, do you want to change the ET reference number and change all of those components to shell 63? Yes, I do. And so now when I export this model into ANSYS, it's going to carry that shell 63 data with it. It won't just stay in HyperMesh. So this part's very important. Now I'm going to close out of this. And what we're going to want to do is I'm going to assume that we've made all the changes that we want to make to this model. Obviously, I haven't made the connections here, but we'll allege that you have done that in your case. Now I'm going to go to export under file. And when you export it, you want to export what's called the solver deck. Now the solver deck is everything. It's the geometry that you input, it's the file type that you've assigned, and it's also the elements. So it's important that you don't export the model and you don't export the geometry. Export the solver deck instead. So we're going to click on that. The file type that we have in HyperMesh, remember we set it to ANSYS. It's already been done here, so we keep it at ANSYS. The template that I want to export as is also ANSYS, so these should match. So the file, I'm going to click on this folder, and I'm going to just say file name is part 1. And here you can see, since we clicked template up here, it's going to save as file type ANSYS files.cdb. So you're going to hit save. We're going to save it to downloads. And export options. You can do custom, all, or displayed. And this is the geometry that you want to export. I want to export everything. I don't want any custom settings, so I'm going to hit all. And here you can make changes. They're very, very small changes. You can not save invalid elements if you want. Failed elements, you can exclude those from your export. But I'm going to keep them, and I'm going to hit export. And down here, you can see there was briefly a progress bar. It showed all the elements being processed, but it says finished, which means I know it's done its job. So we're going to go ahead and check the folder just to make sure it's saved. And it did. Part.cdb, which is exactly what I want. So now I'm going to search for Workbench, which is the ANSYS home software, basically. It contains everything that we would want to use. Go ahead and allow access here. This is just because I'm remoting in. It's giving me some grief. But anyway, so Workbench is going to load very slowly. Okay. Now we are at the Workbench homepage, and if you've watched my other video on the ANSYS tutorial, you probably recognize this. If you haven't, make sure to check it out. It'll help out with understanding what you're looking at. But a brief explanation, you have different things in your toolbox here. So you've got analysis systems, component systems, customs, blah, blah, blah. So I expand the first two, analysis and component, because that's what I usually use. So under component, you're going to see one called external model. And you're going to left click on that and just drag it right into the screen here, create standalone system. And you can see that this box has popped up here. this first one, number one, is always just the label of the module that you're using. Number two is the next step in order of what you want to do. So you can see with any system that I create, it'll always sequentially number what I'm going to want to use. So in this case, I've gone ahead and selected ACP pre as well as external model because I will be using both of these in this tutorial. So I'm going to right click on setup and hit edit. And here you can see it wants me to add a file because I'm dragging in an external file. So I'm going to hit this ellipse here, the ellipses, and hit browse, go to downloads, and you can see that it's automatically searching for the ANSYS file type .cdb. And here's our part that we exported. So we're going to go ahead and open that. Now it's important to click on it because it brings up this drop-down menu, which has properties. And this part's really important. So right here, the unit system, if you don't get it right, you'll have a bad day. So remember, we designed this in inch pound second. Now make sure that you use consistent units. So consistent BIN, which is, I don't know what the B stands for, but the IN stands for inches. And that has worked out so far. So I do consistent BIN because I designed it in that. If I did it in MK, I would do consistent, I would just do the metric because they have all the different metrics here. Kilograms, meters, degrees C. If you're doing temperature, make sure to go all the way through your data and make sure that you have the right temperature unit. So I do that, and there's nothing else that I need to change here. I'm happy with this. So I'm going to go ahead and click out, hit X right there. Now you can see that this little lightning bolt has popped up, and in ANSYS, that means that you need to update your project and let the program figure out what has changed. So here, there's a little update project key. Go ahead and hit that. It will briefly update, and down here you get an information piece. So this is junk. This just means that there was another program that was open, allegedly, or it thinks it was, that was closed because I updated. Don't worry about that. This right here tells you that you need to input user information, you need to input information before you update it. This message kind of comes up erroneously. It's not always applicable to what you're doing. In this case, it's not. It's kind of a baloney message. But you do want to keep track of your error messages as you get them. Now I want to connect this to ACP pre. ACP pre is the program that we use to analyze carbon and composites and sandwich material and stuff like that. So I'm going to left click and drag, and you can see I'm not over to module B yet, but there's green highlights that have come up. The green highlights all the way to the bottom, that's the furthest that I can go. That's the most data that this can provide is up to the model portion, which is step 4. So I'm going to go ahead and transfer A2 right there, and this pinkish purple line comes up. And you can see there's a green refresh symbol here, which is refresh project. There is a check mark for engineering data, which means it has, or it thinks it has what it needs. And there's a lightning bolt here. Updating your project will both refresh and update it. Refresh is just a light version of updating the project. So I have to allow access here just because I'm remoting in again. And I'll take this opportunity now to just ask if anybody has any questions while this is loading about what we've done.
No questions, but I did go out and search element types for ANSYS. And evidently shell, what was that, 63, is one of the element types. And there is a boatload of element types out there.
Yes.
And you need to make sure that you're using the one that's applicable to your solution. So I'm guessing this is a structural element type.
It is, yeah.
And I noticed also that you had shell 63 for quads, and you also had shell 63 being used for triangular elements.
I did, yeah.
Well, and what that's fine, but what you need to know is that's a degenerate quad. And at that place where it goes to the triangular tip, it's going to be artificially stiff at that point. And so you don't want that to be in an area of interest. if you're really trying to nail down what the stress actually is there. It can be great for making a transition in a low gradient area,
Right.
but you can make it look artificially stiff.
Okay, that's good to know. So you're saying the triangles, it'll act as if they're artificially stiff at the ends, like way stiffer than the material properties allow them to be, just at the vertices.
Right, because that thing was designed to do a stress profile across a quad element. Now you've taken one edge and collapsed it to a triangle, and in that area, it's going to be stiff.
Okay, that's good to know. Yeah, I did not know that, but yeah, thank you for looking that up. So yeah, check your element type before you export it. Dr. Kyle, if you wouldn't mind emailing that web page that you found to me, or
Oh, sure.
everybody in the meeting, um, I'll go ahead and put it up on the OneDrive just so people can look. But yeah, so you've seen here all the while this project's been updating, and here you can see a question mark has popped up, which means it wants more information. And basically what we want to do is, I'm going to ignore the material data right now. I could go through and add that, but since I'm not going to follow through with this full simulation, I just want to show you what you need to look for in the context of importing something. So I'm going to right click on model and hit edit. And really what I want to check here is just to see that the mesh has really translated the way that I want it to. So I'm going to hit OK on all of these. And it's going to open up down here, starting mechanical. And it shows this annoying tips page. You can click do not show tips at startup and it won't do that anymore. So anyway, click into here and you can see right now it is displayed without a mesh. Now if we want to display it with a mesh, it's as simple as clicking on this menu right here. Just hit mesh. And remember we didn't connect these elements here, but we did connect elements over here. And I'm forgetting controls for this program right now, so sorry I'm kind of putzing around. But here you can see that it's maintained its connectivity, and we're happy with that. And what you can do, this is also something notable, you can actually create names. And name selections are very, very, very helpful when you go through to do your simulation. You have to do name selections. It's a little tedious, but it's very, very helpful in the long run. So I'm going to go ahead and just show you an example. I'm going to create a name selection. So insert name selection. Oh my gosh. There we go. And it wants me to input a geometry. It's highlighted it nicely, so I know what to do. So I click on it, and you can see apply and cancel show up. So basically, it wants me to select something. Right now, this is on face select. And if you look over here, there's also node select, element face, cube element, or not necessarily cube, but any 3D element. I want to select an element face. So I'm going to hit that, and it redisplays the mesh again because here's my elements. I want to name this, and this, and this. I have to hit control to select multiple. So I'm going to name these ones right here, and I'm going to hit apply. 11 element faces. Great. I know I forgot about these back here, which are also connected, but we're going to ignore those. And what I can do right here, right click and rename it, and I'm going to call these connected elements. Now, the reason I show you this is because this connected elements named selection will follow you all the way through the simulation process, all the way to the end, and you can apply pressures to that, you can apply fixed boundary conditions to that, you can do whatever you want to this connected elements part. So if you want to interact with specific elements, create a name selection, it will follow you through the rest of the simulation process. And that's essentially how you import from HyperMesh to ANSYS. And it's pretty straightforward. And if you have any errors, you can always reference this video. So does anybody have any questions about what we've done? I know I've been doing a lot of talking, so I apologize, but cool. All right. Well, yeah, that's the gist of it. So go ahead and stop recording.